Chapter 14. Applications for Commerce. Business also stands to gain from the benefits provided by blockchain innovations that increase process efficiency and enhance trust. Pharmaceuticals. Manufacturers of medicines have also seen the potential for data blockchains to secure their supply chains and ensure that a definitive record exists to guarantee product quality throughout the manufacturing and distribution process, from the factory to wholesale storage, retail delivery, and the point of sale. By checking the blockchain records of products, consumers would be able to confirm the manufacturing date, the ingredients, and the location of manufacture for the medicines that they purchase. Supplier blockchains could also be integrated to ensure the quality of the ingredients being used in the manufacturing process. It should be noted, however, that when encoding subjective information into the blockchain, unlike currency transactions on the Bitcoin and other transactional blockchains, there is still a certain level of trust that's required to believe that the subjective data that has been encoded is actually truthful and encoded by a trustworthy actor. When a Bitcoin travels from address A to address B at time C, we know for certain that it did in fact happen in reality. The ingredients in a pharmaceutical product still rely on the truthfulness of the person who encoded the data, who may be lying for whatever reason. However, we can rely on the timestamp of the data and the fact that the data hasn't been tampered with since it was encoded. Thus, unlike a traditional database, once the verification data is encoded in the blockchain, it is impossible to alter it later. However, increased confidence could be gained by encoding additional data points like hashes of verification photos that provide further evidence on the veracity of a particular claim. Counterfeit drugs are also a massive problem for the pharmaceutical industry, causing over 1 million deaths every year worldwide. It's estimated that 50% of the drugs sold on online websites are fake, and 30% of the drugs in developing countries have been counterfeited. DHL and Accenture have developed a blockchain-based serial number project with track and trace capabilities that assigns a unique blockchain-recorded identifier to every unit when it's manufactured, detailing the origin, batch number, and expiry. This makes it possible to track any item at any moment and follow the product through its entire life cycle. This information is invaluable as supply chains can be extremely complex, with shipments being aggregated from unit to case to pallet at the origin, then disaggregated as they approach the final distribution destination. The system also documents each step and proves that the product is not counterfeit, was created by a legitimate manufacturer, and was stored correctly the entire journey from origin to consumer. The prototype system has proved itself capable of handling 7 billion individual serial numbers and up to 1,500 transactions per second. Supply chain management. Supply chain logistics is often cited as the perfect industry for the widespread application of blockchain technology, even more so than pharmaceuticals. The adoption of distributed ledgers promises to create faster and leaner systems, superior transparency, increased traceability, and improved process automation. Currently, the logistics industry is complex and varied, with as many as 500,000 different trucking companies in the US alone using many different tracking and management systems. For supply chain managers, one of the biggest headaches is providing authentic products that are ethically sourced and in 100% perfect condition. However, in current supply chain systems, it is also estimated that for a single shipment of fruit, for example, over 30 different people and organizations may be involved in over 200 separate interactions. This leaves a lot of room for mistakes, intentional or accidental. The most obvious place to start is tracking shipments accurately. To reduce delays and fraud, Maersk and IBM have experimented with a system to track shipments and digitize customs documents and the all-important bill of lading, which includes information on the shipment description, the quantity, the destination, how the goods should be handled, and how they should be billed. In the future, RFID tags could be encoded with private keys and cryptocurrency addresses to record their real-time location when in transit. Because shipments travel through so many locations and the tracking database records are modified by so many people, a distributed database structure ensures that the information recorded cannot be changed or altered, essentially providing a single source of truth for all the supply chain stakeholders. This does away with the need for central entities and intermediaries and reduces costs for shippers, consignees, carriers, forwarders, ports, customs agencies, banks, and insurance companies. The data becomes permanent and is easily shared, so it's easy to see the potential for cost savings. Many other logistics players are also already experimenting, and so far the results have exceeded expectations. Proof of legitimacy for pharmaceuticals, as mentioned in the previous section, proof of authenticity for luxuries, ethical sourcing, and ensuring that the original item has been correctly preserved are also problems confronting the industry that blockchains can help combat. For this reason, any logistics blockchain system that achieves mass adoption would also include data like temperature info for the shipping container and tamper alert information in the case that unauthorized persons interfere with the shipment. Blockchains can also utilize smart contracts that enhance supply chain automation, then automatically trigger responses when contract conditions are met, whether that be payments, escrow functionality, or digitized letters of credit. Blockchains ensure contract compliance, as all parties are able to share an unalterable database record of the entire transaction that encompasses all interactions. VeChain is one supply chain project that has gained traction in the logistics industry. Its main functionality is asset digitization that allows manufacturers to create unique identities for particular items using SHA-256 hashing functions. The unique hash corresponds to a unique VeChain ID number that can be encoded into NFC tags, RFID tags, or QR codes, allowing the user to reference the entire supply chain history of the item. The platform also allows users to represent ownership of the asset at each location on the supply chain through smart contract capabilities. Only users with the corresponding private key can transfer ownership of a particular asset. The platform also makes use of VeChain tokens, which are fungible, have a market value, and are used to pay for actions on the network. They are also awarded to nodes for maintaining the network. A foundation with an endowment ensures that there is constant research and development for the platform as adoption increases. The VeChain platform is intended to allow users to track products from the raw material state and check servicing history, spare parts replacement, and all movement through the logistics supply chain. It is also designed to be tamper-proof and secure. Micropayments. Provided scalability is solved, blockchains create the possibility of the widespread use of micropayments. For example, online news sites could charge small 1-cent charges per article read, which would be automatically paid by the browser. Current payment systems don't make micropayments worthwhile. Subsequently, micropayments could be combined with smart contracts to create a new kind of commerce between AI-controlled IoT devices that occurs as they interact. For example, in the future, autonomous vehicles in heavy traffic on expressways could conceivably pay other autonomous vehicles micropayments for providing services like giving way if the other vehicle is in a hurry. Until now, unimaginable transactions suddenly become feasible. International money transfers. One of the most obvious applications of blockchain currencies is, of course, the transfer of money from any point in the globe to any other point in the globe almost instantaneously. As mentioned previously, certain platforms like Ripple have devoted themselves exclusively to this purpose, although some would dispute whether Ripple's XRP currency fulfills the basic prerequisites in regard to decentralization that are de rigueur for cryptocurrencies. For the purer cryptocurrencies like Bitcoin, scaling still remains a challenge, as processing only 500,000 transactions per day, or a little more with SegWit activated, will never meet the demand requirements of a currency that has to operate on a global scale. Likewise, no customer will be happy about paying a $90 transaction fee in order to transfer $500 to a friend on the other side of the planet. Nevertheless, the uncensorable nature of blockchain cryptocurrencies provides an added incentive for their use in cross-border transactions. For example, when WikiLeaks, the whistleblower website, was financially banished by PayPal, MasterCard, Visa, and the Bank of America, they instinctively turned to Bitcoin in order to maintain their supply of donations from supporters all over the world. In fact, in 2017, during the last major Bitcoin bubble, the WikiLeaks founder, Julian Assange, thanked the US government for putting pressure on their banking and finance partners, as that spurred their adoption of Bitcoin and allowed them to profit immensely from the appreciation in the value that Bitcoin experienced. Real-world asset tokenization. As elaborated on previously, creating tokens or securities that represent the value of an underlying asset is an ideal application for blockchain technology. However, a lot depends on how the many legal uncertainties are addressed. Current contract law even allows for an agreement between two parties that was written on a torn piece of toilet paper to be admissible in a breach of contract case, provided that the agreement fulfills certain legal prerequisites. Likewise, even though governments have not yet legislated specifically for smart contracts on public blockchains, in theory they should be admissible provided they too meet the prerequisites stipulated in contract law. However, as none of these contracts has yet been positively tested by law courts to confirm their adherence to legal precedents, most people are still uneasy about the actual legal status of token ownership and how it would be enforced by governments. Thus, before any of this token-based economy becomes mainstream, it needs to be battle-tested in the real world to gain people's trust, just as paper contracts had to prove their worth before being trusted by everyone. If people don't have confidence that their control of private keys for a cryptocurrency address that contains tokens isn't equivalent to owning the legal titles representing the entity, then tokenization just isn't feasible. There are many reasons to tokenize assets, the most obvious being the accessibility, especially if you install a trading app on your phone. Tokens can also be bought and sold in real time, which is not the case with many real-world assets, and the records on the blockchain leave a perfect audit trail, making them attractive to users who need to follow their asset trades and governments who want to collect tax receipts. Tokens can also fit into the existing legal system as derivatives, although many details still need to be ironed out. Once again, while there are a lot of projects focusing on real-world tokenization, just as there are with real estate, as mentioned in the chapter on securitization, contract law isn't the only legal uncertainty. There is also the already mentioned private key problem. What happens when the owner of the private key for the asset misplaces it or it's stolen by another dishonest party? This of course requires legal remedies that reassign the legal links between the asset and the cryptocurrency address to which it belongs, which of course makes them more susceptible to confiscation than pure digital assets. So while tokenized assets may be more vulnerable than cryptocurrencies in terms of their immunity to confiscation, the other side of the coin is that governments will be able to deal more readily with the kind of problems that Bitcoin is unable to manage, like the more than likely occurrence of someone, somewhere, eventually losing their private key. This can be a good thing if you're someone who has lost their key, or a bad thing if you fear government confiscation of your asset. There may also be an added advantage from having all these records freely accessible on the public blockchains, as even if the link between one asset and a token is reassigned, it couldn't be done secretly, as everyone would be able to see the indelible record online. If any government decided to change the link between a particular token and asset, at least it would be out in the open and obvious to the public that something untoward was occurring. Stock exchanges. A number of stock trading platforms like the ASX in Australia and the Nasdaq are researching ways to migrate their platforms to the blockchain. Like the tokenization example above, the biggest challenge to linking blockchain digital assets to some underlying asset like an equity that represents ownership in a company is creating the legal precedents that reinforce the legal connection. Until now, there haven't been any court cases disputing the legality of blockchain assets, so to a certain extent, investors in these new form exchanges would be guinea pigs. Nothing has been promised in the immediate future, but a lot of research and development is expected. Blockchain also has the potential of completely decentralizing the entire exchange process. If a digital currency is used instead of a fiat currency, instead of conducting the trade on a website, a decentralized process means it's possible for buyers and sellers to be matched in a decentralized manner whereby the exchange of assets takes place directly and not through a third-party platform. The atomic swap, a smart contract technology that enables the decentralized exchange of digital assets peer-to-peer, looks like it will play a major role in this, and successful exchanges have already been achieved on the Litecoin blockchain. Much like how one downloads the BitTorrent client to exchange torrent files in a decentralized fashion, users of a decentralized stock exchange or digital asset exchange would all download the same software, and then the software would facilitate the finding of peers who have mutually desirable digital assets to trade. This technology is still in the early stages, but no doubt in the future there will be no reason for users to transfer their digital assets, including stocks and bonds, to a centralized platform in order to trade them with other market participants. Of course, there will be a considerable amount of overlap between the activities of the regulated stock exchanges and the new emerging cryptocurrency exchanges, so to a certain extent, the incumbents will have to increasingly justify their existence by updating the technologies they use so they remain relevant. Cyber attack prevention. The distributed nature of blockchains could be utilized for cybersecurity by increasing the attack surface that hackers have to penetrate. Hackers often gain access to the data stored on restricted servers by taking advantage of the security vulnerabilities and tampering with security protocols at entry points. Because the data would be spread over multiple nodes thanks to the blockchain infrastructure, and consensus is required to force any changes to the data, it becomes very difficult for bad actors to perform these kinds of nefarious actions. Tampering with data would require control of nearly 51% of the network, which is prohibitively expensive, especially if the security system protocols are distributed over a major blockchain like Ethereum. Not even an administrator would be able to alter a protocol stored in this manner, let alone an unauthorized person. Next episode of WTF is Bitcoin, the cryptocurrency and blockchain guide for dinner parties, we'll be reading Chapter 15, Data Management Applications, and we'll focus on the different areas of data management like credential verification, intellectual property management, and decentralized data storage that could be impacted by the introduction of blockchain technology. If you enjoyed today's episode, don't hesitate to like, comment, subscribe, and share this podcast with anyone you think will enjoy it. It really helps us reach a much larger audience.